You can use trigonometric identities to simplify the trigonometric expressions. What's the meaning of simplifying? Simplifying an expression means that each subsequent expression is equivalent to the previous one. Let's solve this problem here in order to find the simplified trigonometric expression for cosecant times tan. In the verifying, I told you you have to find a way to tell me that, or to prove that, cosecant times tan equal secant as an example. Today, no. Today I give you that one, and I want you to simplify it as much as you can. So I can simplify it as a way, but another student simplify it another way. All of them will be okay. So now here we have cosecant times tan. Now, cosecant, how can we write it? As 1 over?
1 over sine.
1 over sine.
And tan, we know it is one as a sine over cosine.
So it's secant.
Sine, cancel sine. So I have it now as 1 over cosine, which is secant of theta. This is here how to simplify an expression. As I told you, simplifying an expression means that each subsequent expression equal to the previous one. So that's mean this part here, secant, is equal to 1 over cosine and is equal to this part and it is equal to this part. So secant or 1 over cosine or cosecant times tan or 1 over sine times sine over cosine, all of them are equal. All of them are the same. This is the meaning here of simplifying. That's mean each subsequent expression is the same as the previous one. So now we convert it from a complicated one as cosecant times tan. We rewrite it as secant. Is it clear?
Teacher, the meeting was locked and some of us didn't enter. Can you repeat it, please?
I just started now. All of them are here.
Yeah, because now I entered.
Okay, here.
Because it was locked.
Here now simplifying. Simplifying means that I need to rewrite this complicated one to simplest one. So cosecant times tan. Cosecant is 1 over sine. And tan as sine over cosine. When you simplify them, we get it as 1 over cosine or secant. Simplifying means that I need to rewrite it in simplest form. Not like the verifying. Verifying, you have to make them equal. Multiplying, adding, make anything, try to cut it, make them equal the second part. Here, no. Here I told you just you need to simplify as the way as you want.
Okay, teacher, thank you.
Let's solve another example now.
This is much easier than the verifying.
Yeah, exactly. Now, here secant times cotan. Now, what's the meaning of secant? Secant, it's 1 over cosine.
1 over cosine.
And cotan, it is cosine
over sine.
Then cosine, cancel cosine. So I have it as 1 over sine. 1 over sine, which is cosecant.
Cosecant.
This is here how to simplify it. Now, this is here the meaning of simplifying an identities. Now, let's solve these examples here. Number 29. Now, in number 29 here, we have cosine theta plus sine theta times tan. So the first, let's keep cosine as it is and sine as it is, and tan, write it as sine over cosine. Then it is cosine plus sine times sine, which is sine squared, over cosine of theta. Now then, here, as you say, now, here we have cosine plus sine over cosine. So the second step that I will think about it, let's make them have the same denominator in order to simplify them. So
Cosine.
here, what did we have? You have to use the butterfly way, or we have to say that this is here over 1 times cosine times cosine.
Oh, teacher, I
So
can't
here,
just
what did
like
we have
skip
now?
them because they are
No,
adding.
don't skip them. If they are multiplied, you can simplify. So cosine times cosine, we have it as cosine squared of theta plus sine squared of theta over cosine of theta. I will repeat here. What did I do? Here, what did we have? We have cosine of theta over 1 plus sine squared over cosine. I need to simplify them. I need now to make them have the same denominator. When we have the same denominator, that's mean I have to multiply this part here with cosine and this part here with cosine. Then cosine times cosine is cosine squared over cosine plus sine squared over cosine. And since they have the same denominator, we can write them as one fraction. So we can write cosine squared plus sine squared over cosine. And then from the Pythagorean identity, we know that cosine squared plus sine squared is 1. So which is 1
So 1
over cosine. And 1 over cosine, as we know, it is secant of theta. This is for number 29. Is it clear?
Yes, teacher.
Yes.
Yeah.
Now, let's go to number 30. In number 30 here, we have cosecant of theta times cosine times tan. Cosecant, let's now rewrite it as 1 over sine times cosine times tan, which is sine over cosine. Now here, they are multiplied. Since they are multiplied, so no need to make them have the same denominator. Multiply, that means we can simplify. But if they are added or subtracted, you need to make them have the same denominator. Then, so we can simplify them. Cosine cancel cosine, and sine cancel sine. So we have them as one.
Yeah.
Now, let's do number 31. In number 31 here, we have tan of theta times cotan of theta plus tan of theta. Now, let's rewrite tan as sine over cosine. And cotan as cosine over sine. And tan as a sine over cosine. This is here the first step. Then, let's first go back to the identities inside the bracket. Here, cosine over sine and sine over cosine. They have the same denominator. Is it right?
Yeah.
So we cannot add them.
No.
So
Wait.
we need to make them have the same denominator. So here is cosine times sine. Here times sine. And here times cosine. And here have times cosine. In order,
Isn't just easier to distribute the parentheses because they will simplify automatically.
Yeah.
yeah, that's another way. Yeah, okay. So let's continue here now. Cosine times cosine, cosine squared, plus sine times sine, which is sine squared, over sine times cosine. All of them are multiplied by sine times cosine. Then, from Pythagorean identities, we know that sine plus cosine is 1. So we have it now as sine of theta over cosine times 1 over sine times cosine. Sine cancel sine. So we have it now as 1 over cosine squared of theta.
Teacher, what if we distributed them like all? What is it like the same?
Distributed them, we get it as 1 plus sine squared over cosine squared. No, we will get this. We will not get the same. We have to continue. And like it will be like this. Hello, before I tell you how to, if you can distribute them. Is this way clear?
Yeah.
Let's see now them if we simplify or if we distribute them. Shall we get the same answer? Just 1 minute, please. This is, we say that this is sine over cosine. Here we have it as cosine over sine plus sine over cosine times sine over cosine. Now then, cosine cancel cosine, sine cancel sine, so we have it as 1 plus sine squared over cosine squared. Then we have to make them have the same denominator. So we have it as cosine squared plus sine squared over cosine squared. In other words, as 1 over cosine squared. So we get the same answer, but as I told you in other way.
Yeah. Okay, teacher, thank you.
Yeah. Is it clear? Now for
I
number
can also
20.
say,
Oh.
because we had in the last step we had 1 plus tan squared. We don't like need to unify the denominators. We can just use the Pythagorean identity. Say that is equal to secant squared.
And yeah, and it could be the same also. Oh. And then area 1 over cosine squared, you can write it as secant squared.
Secant. Yeah. And but teacher, if we have it like that, it's okay, right?
Yes, yes. You
Okay.
have to get the same answer. Or here, as she said, 1 plus tan squared equal secant squared. This is also a third way. Now, 29, 30, and 31. Please, the others, are they clear?
Yes,
Maya, Habiba, Sarah, Lana, Lama. Are they clear?
yeah.
Okay. Now, number 32. In number 32 here, we have sine squared plus cosine squared plus tan squared. We need now to simplify them. Sine squared. This is the simplified one. Cosine squared. This is the simplified one. And tan squared, we can write it as sine squared over cosine squared. So then here we have them as added with different denominators. The denominator here as cosine, so we can multiply them here by cosine
Same
squared
by cosine.
and here by cosine squared, by cosine squared, and here by cosine squared. Then up here, what did we have? We have cosine squared, sine squared, plus cosine squared times sine times cosine squared plus sine squared over cosine squared of theta.
Teacher,
Now then, yes,
there is an easier way. We can say sine and cosine equal 1. So we can say 1 plus tan squared, which is secant squared.
yes, exactly. This is the way. Now let's continue here. Yes, thank you, honey. Now let's continue here as I reach. Now I stopped at this point here. So let's make a space first. Now then, if we take cosine squared as a common factor up here, what did we have? We have sine squared plus cosine squared plus sine squared over cosine squared. And then sine plus cosine, they are 1. So cosine squared plus sine squared over cosine squared. Then cosine and sine, they are 1 by the Pythagorean identity. So it comes like 1 over cosine squared, which is secant squared. This is how to do it. Is it clear?
Yeah.
Yes, yes. Thank
Now, as you see, each of us think as an always, and I think as this way, Haneen think as another way, and the previous one I think as a way, and Susan think as another way. So this is here how to simplify. You can use a way as you want. Now let's solve number 33.
Teacher, can you go back like a little bit? Okay, teacher, I'm done. Thank you.
Number 33. Sine of theta times 1 plus cosine squared. Now, yellow, how do you think? How can we solve it here? One plus cosine squared is
We
what?
can.
Cosecant
We
squared.
need to distribute the parts. Or we
no,
can
like
use
first
one. No.
We
Why
can.
the
Yeah. Thank you. Hala,
No,
Sultan,
the
as you said,
answer
we
is
can
equal
distribute
sine.
sine times 1, then sine times cosine squared, and continue. And we can say that 1 plus cosine squared is cosecant squared. So, sine of theta times cosecant squared. Cosecant is what? 1 over sine. So cosecant squared will be 1 over sine squared times sine. Then sine cancel sine. So we have it as 1 over sine.
Which is cosecant.
Cosecant. Bravo. This is here for number 33. Now number 34.
Teacher?
Yes.
Teacher, since cosine squared is equal cosine over sine, can I do this one?
Yes, you can.
Teacher, like if we have cosine squared, the answer of the cosine squared, it will be cosine squared over sine squared, or no?
Sine squared over cosine squared over sine squared. Yes.
Yeah, okay. Thank you.
Yeah. Now number 34. I want you to please try it on your copybook or notebook and send me the answer on WhatsApp. Now, I want to see how do you think.
Okay,
Number
teacher.
34. So, number 34 now. Sine squared times cosecant, thank you, Sarah, times cosecant times secant. Now, sine squared times cosecant, which is 1 over sine, times secant, which is 1 over cosine. Then, sine cancel sine, so we have as a 1 sine over cosine, which is tan of theta. That's it. You have any question?
No, teacher. Thank you.
Thank you so much. Have a nice day.
Teacher,
Yes.
last period we are going